I'm Professor Jon Tunge. I've been here at the University of Kansas for 23 years now. And my background, so I got my BS degree at the University of Idaho in 1995. And there I worked on detection devices for high explosives. I moved from there and I went to Columbia University in New York, where I got my PhD. And there I worked on organometallic mechanism and synthesis. And then I moved to University of Wisconsin, where I did a postdoc for a couple of years with Chuck Casey, where I looked at mechanisms for alkene polymerization. And I kind of took a hodgepodge of those things and blended them together in what I do for my current research. There's a problem in chemistry in that the traditional ways that we do chemistry are both wasteful in terms of energy and in terms of material. And so I just try to come up with better ways to do chemical synthesis that don't really waste a lot of energy or waste a lot of material. And we do that by a couple different ways. So we try to utilize energy that's sort of inherent in molecules and release that to drive the formation of really reactive species without energetic input. Then we also try to utilize strategies for converting things like biomass or renewable resources into useful materials without creating a whole lot of waste. The role of students in my group is everything. So students are kind of the lifeblood of any research group, and they do all of the reaction planning, implementation. They do the experiments and analyze results from those experiments. Typically in my group that involves like determining the structures of molecules that we made in reactions that we performed. But the students that graduate from my group kind of fall into a couple of categories where they either go into academics or they go into industry. And within academics, students from my research group have gone on to have research careers at major universities across the U.S. And some of them go on to have similar educational responsibilities at primarily undergraduate institutions. But I would say most of the students that go into industry end up working in some aspect of the pharmaceutical industry. Training in my lab also prepares students to work in industries like commodity chemical synthesis or even petrochemical industry. And so I have some students that have gone on to careers in those industries. We find kind of natural collaborations with people, say, in medicinal chemistry or pharmaceutical chemistry. And I also help direct a program that studies infectious disease here at KU. And there's a natural connection to a center we have here, the Center for Environmentally Beneficial Catalysis. And people in the theory groups can really be awesome collaborators because they can help answer questions about reactions that we do where experiment alone can't really provide those answers.